Hi, I'm going to make a series of videos where I make quantum mechanics as easy as it can ever get. In this video, we'll start with the very basics. But before that, please don't forget to subscribe to my channel. It's free and it keeps me from getting depressed. First of all, this paper ball here is all your knowledge in classical mechanics, or basically everyday physics. Now, the first thing you're going to have to do is, in classical mechanics, every particle has a proper position. It is at one place at a time. In quantum mechanics, when you disturb particles, for example using light, here physicists like to use many terms. Instead of disturb, they like to use the word measure. Okay. Anyways, let's continue. When you disturb particles in quantum mechanics, they act the exact way that they act in classical mechanics. There's nothing different until now. But when you let a particle stay undisturbed, a particle will act like a wave. In the sense, it can have multiple positions at the same time. Here, physicists like to use the term quantum superposition. The idea is that when you disturb the particle, the wave of positions of this particle collapses into a single point, and this point is the position of the particle when you observe it in classical mechanics. For example, let's say that I have a coin, not a regular coin. It's a special coin which has quantum superpowers. It can be in a state of heads, tails, or both at the same time. As you can see here, it can be described by a wave. The wave describing the position of this coin or the states of this coin has two humps. One of the humps is for the state heads and the other is for tails. For any wave of a quantum object, the taller the hump, the higher the chance that the particle will be there when you observe the wave. Since a quantum coin acts similar to a normal coin, it has a 50-50 chance of being heads or tails, which is why both humps in the wave of the quantum coin are at the same height. Okay, so a recap at the very end. So basically, in quantum mechanics, as long as the particle is being observed, okay, now so you guys don't get confused in the future, observe can have many meanings in the sense. Like for example, when you shine a flashlight, you're disturbing the particle in a sense because you're shooting a photon at it. I mean, here a good visualization, a way of imagining the concept would be that the particle is one ball and the photon is another ball hitting on that ball, and that disturbs it in a sense, right? But another way of thinking of it is a quantum system can be disturbed by air molecules, because you could again use the visualization of two balls hitting on each other here. Okay, so with the recap, quantum mechanics is exactly like classical mechanics when the system is disturbed, when the particle, for example, is being observed when you like shine a flashlight on it, or the air molecules are maybe interacting with the system, for example. But when the system is undisturbed in the sense, then things get weird. The particle is not described by a single point anymore, it's described by a wave. This wave can have many humps, signifying what the chance is that the particle has that specific state or is in that position at the wave. And the higher the hump, the higher the chance that the particle takes that position or state. I say state because look, with a particle, you could maybe use the wave to show the position of the particle, but with a special quantum coin, it can be, you can show the wave for states like heads or tails, which is not exactly position of the coin. So When this wave collapses, it turns into a single point again. I hope you guys are able to understand this. If you guys have any questions or things you don't understand, please let me know in the comments. I mean, like, making YouTube videos and explaining to people is quite new to me. In the next video, we will see proper proof of this phenomenon, because I accept the fact that it feels weird and it feels like it doesn't make sense to believe something without proof. So in the next episode, we'll look at the double slit experiment, the first proper proof of quantum mechanics, and the wave-like behavior, basically the multiple position behavior of particles.